Okay, so this question is from the topic of heating effect of current. Very important topic, and you would have seen many questions pertaining to the power given for bulbs, right? Then the bulbs are connected in parallel series, and then they ask you which bulb will be brighter, which bulb will be dimmer. So read the question. You're given two bulbs. One bulb is rated. I'm using the word rated. So the rating of first bulb is 25 watts and 220 volts. Okay. The rating of the second bulb is 100 watt. Okay, so it is 100 watt and 220 volts. Okay. Then, what is the question? Which bulb will grow brighter if they are connected in series? Now you connect them in series. Okay, so this is your situation. Okay, and after connecting them in series, uh, okay, the question is which bulb will. So I will just reduce the size of the question now so that you can see what is that I'm writing. So, all right. So let's discuss. So first of all, when they give you the rating of the bulb, what exactly is the significance of rating of the bulb should be clear in your mind. See, the way to look at rating is if you're given this information, which is available in front of you, what you do is okay. What you do is this. Just give me 1 second. All right. I think this should be better. Right. All right. So what do you do with the rating? The first step is to find the resistance of the bulb. So the resistance of the bulb will be given by V square by P is equal to 220 square by 25 watts. Right. So this is R1, the first bulb. The bulb number one has this much resistance. The second bulb has the resistance of R1 and R2. So this will be 220 square multiplied by the power of the bulb. This is the second resistance. So first step, always calculate the resistance of the bulb using this information which is available to you. Now, if you read the question, one thing I didn't like about the question is it did not specify that when you connect the bulbs in series, what is the voltage you have given to them, right? Okay, so I'm assuming the voltage is still 220 volts and the available voltage is 220 across which two bulbs are connected. Okay, so this is so the way I look at it is the bulb number one is here, the bulb number two is here, and the available voltage to me is 220 volts. Okay, this is the way I am looking at it. Okay, that's my interpretation. Okay. Now this is R1 and this is R2, and therefore this particular voltage, right, will get split across the two resistors. Okay, we know the value of the resistor, they're in series, so therefore the total resistance is R1 plus R2 is equal to 220 square divided by 25 plus 220 square divided by 100. Right? This is a combined resistance when they're connected. What is the current in the circuit? We apply Ohm's law. So the current in the circuit, and they're in series, and therefore the current is same. The current will be V divided by R1 plus R2 is equal to 220 divided by 220 square divided by 25 plus 220 square divided by 100. So 220 gets cancelled, right? So this 220 square, you left with 1 divided by 220 upon 25 plus 220 upon 100 is equal to 1 upon 220, and this is 1 by 25 plus 1 by 100 is equal to 2500 divided by 220, and this is 100 plus 25 is equal to 2500 divided by 220 multiplied by 125. I'm just doing your normal calculation, trying to find out what is the common circuit flows in this scenario. Okay, so let me just see. This is 125 20s are right. This also goes away. The current is 1 by 11 ampere. Okay, this is the total current available to me. What is the uh, voltage across this? The voltage across this will be, or I can say, what is the brightness can also be calculated as I square R. Why is that I'm applying I square R? Because they're in series, they have common current. So I can apply I square R. So I apply I square R, which is 1 by 11. So I'm seeing the power being given to the first bulb, which will be I square R1, right? So I'm writing I square R1. The second bulb will have 1 by 11 square into R2. Now, that means it boils down to what? It boils down to the fact that power in a series circuit is proportional to the resistance, right? Let's see whose resistance is high. Obviously, you can see the resistance of R1 is higher because it is 220 square by 25. The resistance of this will be 1/4 because it is divided by 100. This is divided by 25. So this R2 is basically equal to 1/4 of R1, right? So which means the value of R1, right? The power in R1 will be very high. Most of the power which will be delivered by this source will go to R1 because yes. So okay, let me just so the resistance here is high and R2 is one. Yeah. So most of the power will get delivered to R1 because its resistance is very high. So the answer is the 25 watt 220 volt bulb will blow brighter, right? So it'll give you more light. Now, if you individually look at them, obviously this is 25 watt bulb, so it will give you less light. But the moment you connect them in series and try to compare, the situation changes drastically, and the brightness appears in R1 because the resistance of R2 is low. Okay, finally, see, it boils down to your. So there are two things you must remember. If the same bulbs are connected in parallel, then what happens, right? Then what happens is if the same bulbs are connected in parallel, right? So if you connect them in parallel, so this is 220. So both are getting 220, which is no different than their individual ratings. The situation will be 100 watt will be brighter. For the simple reason it is 100 watt and you have given it 220 volt and then in parallel. For equal voltages, which is 220 volts, the 100 watt will glow brighter, right? We already know the resistance of R1 is greater, right? So this resistance of R1 and this is R2. So since R1 is very high, the current in I will be low, right? Therefore, it will glow less, right? Or you can say that the value of V square by R1, since R1 is high, will be less than V square by R2 in the case of parallel situation. So be very careful when you do these questions. Are they in parallel and series? If they come in series and the voltage you've applied is same, then the approach is to calculate the current. But there are certain cases in which they change the voltage from 220 to maybe 440. Then you have to calculate the current and then decide what happens because increased voltage means increased current. But really speaking, since the resistance of R1 is high, it gets more power delivered for the same current. So thank you very much. I hope you like this question. Heating effect of current is an important topic which you need to do. Please go to my playlist of current and electricity. You will find a lot of practice questions. You will find a lot of conceptual questions which will help you understand physics in a better manner. The objective of this channel is to simplify and bring a lot of clarity for you with the help of solved problems and a lot of theory and concept builders. The less clarity you have, more frustration will you have. So I've taken the task of bringing clarity so that you can gain confidence, you start loving the subject and can score high in your examination. Thank you very much and wait for my next video.